So I'm going to quickly share a concept here called binary search. So binary search can quickly search through an array of elements, and by basically doing a divide and conquer. So it's going to take a sorted array of elements. That's the requirement. And it's going to try to find by something in the middle, see if it's there. If it's not there, but it's on the left side, then it's going to take this side, split it in half, and then search again. If it's greater than what's here in the middle, then it's going to take what's on the right side, split it in half, and then try to look for it again. And it's going to continually search and search until it finds it. So here I have an array of some elements, and I'm going to look for the value of 5. So I'm going to debug. And now I'm right before entering the function of binary search. So I enter in. It's going to look at the left and right of what we're going to be searching for. So the left is the edge of the current array, and the right side is the edge of the current array for now. It's going to compute the middle. So this is the middle at index 4. And at index 4, at this array, it's actually going to have the value that we're looking for, which is 5. So it's found it, and it's going to return that index. So now it's saying it found it. So here, it found it at index 5. But now let's try something a little bit more different one. Let's try looking for 8. So it's this side. So we're going to try again. Search, entering into the function, walking through. Okay, it's looking at the middle. And is the middle one item the 8? And it's not. So it's going to say it's not it. So it's going to basically change and look over on the right side. So it's going to say, okay, since the element is the element less than our midpoint? So it's yes, it is less than our midpoint. I mean, our target is greater than our midpoint. So it's going to switch over to our left to be the mid plus 1. So it's going to try again. So now it's saying the mid is at 6. And what's at the element at 6? It's 7. So it's going to try it, comparing again. That didn't match. So now it's going to, one more time, it's going to check again. It's saying, okay, I'm on the right side of my mid again. So I'm going to update my left endpoint. Now it's going to calculate the mid again. The mid this time is 7. So now it's going to look at 7. 7 happens to contain 8. This is going to match, and it's going to return. So now this time it was able to loop through that 3 times and get the index value that we were looking for. So it said it was able to find it at index 7. But as we observed, this loop went through 3 times to find it versus if you were to just do a sequential search going through all this, we would have to loop through this 1, 2, 3, 4, 5, 6, all the way till number 8 to find the value 8. So looping through 3 times versus looping through 8 times is a significant improvement.